Hi everyone. In this video, let us see the lead code problem number 507, that is perfect number, which is from easy level. So first of all, so perfect number definition is given here. So all of you check it once. A perfect number is a positive integer that is equivalent to the sum of its proper divisors, excluding the number itself. So that is without considering the given number factor. So we need to add all the left or remaining factors. Okay. So if that result is equivalent to the given number, so then it is called the perfect number. Okay. I hope so. You understood the definition here. So that is a divisor of an integer x is an integer that can divide x evenly. Okay. So here, next statement, observe this. Given an integer n, return true if n is a perfect number, otherwise, so return false. Okay. So here 28 is the perfect number. So the reason is, observe this. What are the proper divisors of this one? Okay. So 1, 2, 4, 7, and next of all, so the 14, right? Okay. On adding all these values, you'll get the result 28, which is matching with the input. We need to return the true. Okay. So if you take 7, so only the factors you'll get it is 1 and 7. On taking the 1, it's false. Okay. Not matches with the given number. Observe the constraints here. This is the main thing. So for this problem statement, num values lies in between. So 1 to 10 power 8. Okay. And so you can check the topics. It's from math, and after that, so as usual, so try to complete the remaining similar questions. So let us take the another perfect number here. So that is let us take value 6. Okay, input 6. So what are the factors of 6? 1, 2, and next of all 3 by excluding the given factor. So on adding these factors, okay, what is the result you'll get? So 6, which is matching with the input value. Okay. So for this, we need to print the true here for the problem statement. So I hope so you understood this. So actually, this is extension to the factors, okay? But what happens if you directly follow that? I'll explain. First, let me complete the factors program here. That is, let us take input value, and here factors. It's not required to generate up to the given number, okay? Only we need to generate up to the half of the number. The same thing you can observe here in examples, okay? For 6, we need to generate up to 3, and next of all for 28, we should generate up to the 14. We should exclude the given number factor, right? Okay. So after half of the number, the next factor is given number only. So means it's not required to generate all these values, okay? I'm excluding so that so here observe I am just generating values from 1 to half of the number. So here on taking just half of the value, it won't generate that half of value. Okay. That's why we need to add +1. Okay. Next. On dividing n variable values so with I variable, if we get remainder 0, okay, then I variable value is factor 4. So n variable, right? We should print I onto the output screen. Let us take value 12 here. So what are the proper divisors of 12? 1, 2, 3, 4, 6. Okay. So you can check. So on adding these 1, 2, 3, 4, 6, okay, you won't get the result. So that is the 12. That's why 12 is not the perfect number here. Okay, just displaying the factors for some particular number. That's it. So this is the program. So for generating factors, so here what you need to do instead of printing the factors, we need to sum. So the factors here, okay. After performing so sum, we should check whether that sum result is matching with the input value or not. If matches, we need to return true, otherwise so false. First, let us implement this solution. Afterwards, let us see the problem. Okay. So then let us come up with the best solution here. Okay. So observe what I said. So it is sum model program, right? Initially, we should take sum to 0. Here already some called method is given. Num variable given. We need to work with that variable here. We need to return the Boolean values here, true and false from the method. Okay. And so what I said, factors, right? We need to generate factors. So from 1 to half here. And next of all, we should check whether num value is divisible with I or not. If it is divisible, so we should go for adding that sub factor. And finally, we should check whether this sum is matching with the num or not. Okay, if matches, it returns true. Now, if not matches, it returns false. Let us test and submit this first of all. As base test case executed, let us submit it and check. See, observe, we are getting time limit exceeded error here. Okay. So out of 98 test cases, only 62 test cases so passed here. So the reason is, so I'll explain. So here, observe the constraints. Okay, num values lies in between 1 to 10 power 8, right? Okay. For suppose, let us take so num variable value as some 10 power 8 here. Okay. So for that, how many times? So this one. Loop iterates here 50 million times it iterates, okay, right, half of times we are iterating, so loop for half of times, right, okay. So, and apart from that, so observe here, you all know that modulus division is the costliest operation. So here, okay, and for 50 million operations, so 50 times, 50 million times loop iterates here, and 50 million times modulus division operation, comparison operation, and sum operation, all these has to be performed, okay. So operations, so cost involved here, okay. So all this leads to the time limit exceeded here, okay. It's very costly, it takes more time here, okay. So that's why we are getting so the TLE error for this program. So now I'll explain how to reduce so how to resolve this error here, okay, reduce the time complexity. So let us take so the input called so 12. So, what are the factors of 12? 1, 2, 3, 4, 6, right? Okay. By excluding so the given factor. So, let us take so 12 also. First of all, let us take so the factors of 12. So, here we have an important approach. So, actually, we observe that approach in prime number program also. Okay. So, that is we generating so the factors up to the square root of a number. Okay, so that is what is the square root of so 12, square root of 9 is 3, square root of 16 is 4, square root of 12 lies in between something, so 3 point something you'll get, right? Okay, so now here on converting so this one into the integer, you'll get 3. So we need to you'll get square root of factors up to the square root of factors. Okay. So I'm running so the loop here. So square root means we can reduce the number of iterations. And what about so the remaining factors here? Okay. I'll check. I'll tell you here. If you observe the factors, you can form pairs like this. Okay. So that is uh, one is smaller one, another one is the so one is smaller to the square root value. Another one is the large one. Okay, so that is 1 and 12 you can form as one pair, and so 2 and 6 you can form as another pair, and so 3 and 4 you can form as another pair here. Okay, so here, so the first factors you'll get, first factors are less than of square root values. Okay, you can check here, and the remaining values you'll get, so by dividing given number with the first factor here, and dividing, so given number with the 12, 12 divided by 2, what is the quotient? 6. Dividing, so 12 with the 3, what is the quotient? So 4. So you'll get these factors here. So the idea is, initially we need to start, so sum from the 1, and we need to start generating values from, so for loop we should generate, so from 2 to square root of n plus 1. Okay, so means in Python, if you take the square root of n, it runs before to the square root of n. So for running up to the square root of n, so means up to this 3 value, we need to take square root of n plus 1. Okay, so in that scenario, what so we are saying here is, if we found, so the num value means, let us consider that we taken this one into n. If we found that particular value is dividing, then we need to, so add both here. So the I variable value, and next to that, so these are the I variable values we are getting, 2, 3, all these we are getting into the, so I here we are adding it, and so next of all we should go for adding, so up to 6 also, right? The 4 and 6 values we need to add. How we'll get, so the 6, what I said, and given and give dividing given number with the, so first factor, right? What is the first factor? So the 2. What is the next factor? So 3. Dividing given number with the next factor 3, so you'll get the quotient one. So we need to add these values also, right? So that's why I'm taking this expression here, that is n divided by, so the I. So smaller factors less than of square root you'll get, so into the I here. Okay, so for I from, so the 2 to square root of n here. Okay, and next of all, next to that, so square root factors. Okay, you will get on dividing given number with the, so factor values, so that is 2 and 3. So I hope so you understood. So let us check by executing this one how much time it is going to take now. Okay, so let us reset and start the execution of this. And here one more thing you need to note is, so n value starts from 1. What is so here one test case might be failed if you do not take, so the base condition. For suppose if you take 1, num value as 1, what are the proper divisors of 1? 1 only, right? Okay. So for that, what happens? So it is going, for that there are no proper divisors for 1. Only one factor we have. Okay. So that's why 1 we are not considering as, so the perfect number here. So in that scenario, what we need to do, if num value is 1, we need to return the false. Okay. If not 1, what I said, initially we should start sum from the 1. So because we are not going to consider this pair here, we are starting generating from these factors. Okay. And so these factors on dividing with the given number, we are going to get remaining factors. Okay. Larger factors here. So observe for I in range of, so 2 comma um, int of num square root means you can take like this. Okay, I'm multiplying num with 0.5, so you'll get the square root result. I'm converting into integer and adding 1 here. Next, if I found, so number on dividing with I, we get, if you get remainder 0. Simply what I'm doing here, so I variable value I'm adding, and next of all, so number on dividing, so with I also I'm adding here. Okay, let me explain for some sample input called ful. Okay, so initially, So for 12, I already said square root of 12, it's nothing but 3 point something, right? Means loop iterates for only two values, 2 and 3. Okay. So for 2, what happens? So condition becomes true here. So here, so initial sum is 1. Initially, sum we taken 1 first. Always 1 is factor, right? For every number. That's why I taken sum to 1 here now. S is the sum value 1. And what is the current I variable value now? It's 2. And so num value is 12. 12 on dividing with, so 2. What is the quotient you'll get? So 6 here. Observe. We are adding 1, 2, 6 values here. So means result is 9. What is the next value? 3. Again, so 12 on dividing with the 3 also this condition becomes true. Okay. So what you need to do, S is equals to, what is the current sum now? It's 9. 9 plus, what is the current I variable value? 3 plus and a given number and dividing with this factor 12 and dividing with 3, what is the quotient you'll get? So 4. I can check now. So the result is 16 here, which is not matching with the 12. That's why it is going to return false for this. Okay. On comparing sum with the given number, it is going to return the false. If you take some value called so 6 or else 28, for this it is going to return so true. And here number of iterations we are reducing here. There what I said, 50 million instructions it takes, right? Okay. But if you take some 10 power 8 value here, so just loop iterates for 1000 times now. It's a square root. Square root of 10 power 8 is nothing but 1000. 1000 iterations it takes, and time complexity of this one is order of square root of n. And so although some in operations are involved here, number of iterations reduces, right? Obviously, it executes. So fine now, it takes load time now. So base test case executed here, and now let us submit this and check. Observe now how much time it's taking. That's just 7 milliseconds. That's it. Sometimes so it takes 3 milliseconds also. It depends on the net all this. So the same program you can check here. So it's executed within 3 milliseconds here. So this is a solution, best solution for designing perfect number program here. I hope so each and everyone understood this. So that's it. So thank you everyone.